My name is Tony Mason, and I am presenting on my project, Creating More Effective Operating System Education. The goal of this project was to look at better ways of delivering operating systems training. My emphasis was on interactive training with an eye towards ultimately stronger gamification of the operating systems learning process. We know that operating systems education is important to overall success in computer science. After all, it is the foundation or the basis of everything else that we do. However, we have learned in our own OMSCS program that operating systems training is difficult and it has a high dropout rate. We've seen dropout rates of as high as 50% for some of the operating system classes. Now, admittedly, these are informal numbers, so we have to take them with a grain of salt. It would be interesting to look at how we could measure that more effectively or obtain data that actually indicated how many students really dropped out. That would include students who basically stopped participating in the class, even though they had gone beyond the withdrawal date. And from personal experience, I've seen that actually happens. So I decided to use Opia to try and create this interactive training. The approach that I've taken has been interesting in that some of the time constraints have ultimately taught me to be more effective in utilizing pre-existing material. I decided to talk about 4 specific areas: processes, threads, scheduling, and synchronization. The actual Opia site is here, and at this point I'm going to do a walkthrough of the Opia site, and then when we're done with that, we'll come back here and finish talking about my overall project. So now let's take a dive into the actual project itself. This is based on the materials that are loaded on the Opia site that I built. There is a link to the Opia site in the supplementary slide materials as well. But just in case you don't have those, it's fsgeek-test-opia.appspot.com. In designing the materials for the project, one of the things that I was trying to do was gain a better understanding for how to exploit this medium as a way of improving operating systems education. So we use the standard Opia exploration technique. Each of these represents a different card, a small piece of information that students can review. One of the things that I tried to do throughout the entire presentation, and including right here at the very beginning, is to link out to external sources of information. When doing that, I tried very hard not to rely on a single source of information, but instead refer to what I found to be good sources of information from a broader range of different locations. Part of that is because it also allows the students then to gain a greater appreciation for different source locations for this. This is an example of one of the most complex cards I have, actually, where I'm asking the students questions and they're expected to answer it. Once they answer it successfully, they will proceed on to the rest of the presentation. The entire exploration itself is roughly 25 cards. Most of the cards are short, like this one, very short pieces of text. Not so much in this module, there's a little bit of it, but in later explorations, I strived very hard to also include multimedia content. For example, you will see videos, you'll see pictures, those sorts of things. Even in the processes module, there are some of those things. In many cases, the videos that I used are links to existing YouTube material. Opia makes it very easy for us to share YouTube material. So let's go look at the other presentations quickly, or the other explorations. So this is the threading exploration. It is the logical follow-on from the process exploration. So here we ask the student, have you taken the process exploration? If the student says anything other than yes, then they're taken back to the gallery. They can't go back and change their minds. OPIA doesn't allow that. So they actually have to start it all over again. So let's start it over again this time, and we'll say yes. And now what's going to happen is it's going to say, great, let's go look. So here's another one of those links out. When you do click on the links, they don't replace the existing page. Instead, they become either new pages or tabs within a tabbed browser. And my goal was, these are supplements, they're not replacements. So you're not supposed to leave the context of the primary presentation. You're supposed to go and it's like opening up a book, and you can actually read something, and it will explain a little bit more about that. So we can continue on through the presentation. Here's an example where we have more graphics. So we're talking about different threads and what they actually do, and how a single browser might have multiple pages with different threads that do things like notification. Another goal was to try and keep the cards relatively short. This is about as large as a card gets in the presentation, and in most of the cases it's actually considerably shorter than this. From here we then branch out to lots of different possible areas for study. Throughout the presentation, you'll actually see that I also try to cover both Linux and Windows, since I know quite a lot about Windows internals, and Linux internals are relatively straightforward. I'm familiar with Unix platforms, and the source code is available, so it's not too difficult to go through and figure these things out as I'm presenting all of the material. One of the goals here was to help balance the material for students, because Linux and Windows are probably the two platforms with which they will have the greatest amount of interaction in their careers. So let's quickly look over at there we go. The scheduling. And scheduling is a much simpler module than processes or even threads. Although that permits me to go into greater information or detail as we start discussing scheduling. It's like, well, what is scheduling? But let's talk about more interesting issues in scheduling, like real-time scheduling. Now, I'm actually not an expert on real-time scheduling, so I can easily go to someone else's presentation. And so this is just one of the many presentations. In order to keep the material flowing, I've set this up so that when you open the card, it actually starts auto-playing. You'll note that there are full controls here. You can actually go full screen, but that way the student can start immediately moving into the video. I actually liked the way this worked, and this is something that I would continue doing, and in fact trying to do more of. It seems like a very effective way of providing depth to the presentation material without burdening the developer, in that case me, with the need to recreate something from scratch. And again, just like where I was using links from different sources, I've also striven to use different source locations for different material. Now, of course, my most important thing is I want to make sure the material is reasonably correct and appropriate for the audience that I'm trying to address here, which are people who are trying to learn operating systems. So that's fun. So let's go and just quickly touch on the last of the discussions, and that is synchronization. Now when we get to synchronization, it will also ask us if we've been through the threads exploration. And so you'll notice that synchronization and scheduling are parallel to each other. You could actually take them in either order. So we have a nice intro slide. Now here is a case where I used a lot of a number of pictures. I picked a particular motif here, the analogy of synchronization, similar to the way that we use traffic signals to control traffic. And it's surprising how many amazingly good pictures there are of traffic snarls and traffic problems, and so I show the automobile equivalent of not having locks is things crash, and that's a pretty standard part of the process. Now you can see here we have yet another picture. This time it is of a just a simple stoplight. So this represents a mutex, or mutual exclusion, and the material continues on. Now this is a typical kind of card in the exploration, and that is that we don't have a lot of text. There are some links out to supplementary information, so if there are terms that are not familiar to students, we can go link out to it. Students using this can actually provide feedback as well, so that we can hear back from students and try and incorporate that moving forward. It's clear from even this modest beginning that creating this kind of material is really a process of evolution, continuous feedback, where people use the material, they provide you with feedback, you modify the material, and then you continue to get more feedback on it. And since the material here is still fairly new, it hasn't been used in a class yet, the amount of feedback has been modest at best. And there's been at most roughly 24 people who have provided feedback on it. Not all of whom are from the class, actually. And 2 of which have actually provided more than trivial feedback. One of which has provided a lot of editorial feedback. One person provided both editorial and content feedback. Both of those are valuable, and they make the final presentation a successful one. So I leave it to, as an exercise to the viewer, to actually go through these individual modules at your own pace and provide me with feedback. I'd love to hear from you. There you go. Thank you. So now that you've actually seen a brief introduction to my explorations on Opia, let's talk about the conclusions. One of the most important conclusions for me was that this really reinforced how difficult it is to develop effective online material. That doesn't mean that it's not worth doing, it's just that it is a very resource-intensive activity. My observation is that Opia is not yet ready for prime time. It is a useful tool, and I was able to achieve something with it, but I wasn't able to achieve the level of gamification that I had actually hoped for. Ultimately, I view this work as being a springboard from which to build more material, to gain further insight, to build a mechanism by which I can actually evaluate the efficacy of the training for students, because none of this has any point if we don't actually improve retention rates and we don't actually keep students more engaged and more interested in the topic. Another aspect that I'd like to incorporate, this is clearly in the gamification area, would be a PvP style programming activity where you give students a challenge to implement. And so, for example, a client server. And then you have the student swap, so that each student now gets to try and break the other student's project. And this creates a certain style of adversarial proceeding, like player versus player, but it would encourage real, genuine participation in peer feedback in a competitive venue. Uh, I hope to add this to some future iteration of this material, and I'm just leaving this idea here for anybody else who might want to pursue it as well. So that's my presentation. I hope you have an opportunity to read the paper, and I look forward to hearing any feedback you might have. Thank you.